So let's move on to the bone cells involved in bone homeostasis. There are three main bone cells, and the ones that everyone knows are the osteoclasts and osteoblasts. And then osteoblasts can further differentiate into osteocytes. I'll go into osteocytes in a minute, but let's start with osteoclasts. Here's an illustration of osteoclasts and blasts from Canva. The one on the left is an osteoclast. Osteoclasts are special in that they are giant multinucleated cells, which are formed from macrophages or monocytes, which are a kind of pre-macrophage. There's more than one pathway to induce the creation of osteoclasts, but I'm just going to show you this one, which involves the secretion of rank ligand by osteoblasts. And rank ligand triggers bone macrophages to combine to form the supercell osteoclast, much like the Japanese transforming robots Transformers when they combine to form a super robot. So you might know macrophages are the major types of phagocytic white blood cell, which are stationed all throughout the body and are the cleaners, such as removing debris, dead cells, cancer cells, and so on. And osteoclasts are formed from macrophages, or they can be formed from macrophages, which may help to remind you of their function as cleaning up old bone. And you could use the Cl portion, the Cl portion of osteoclasts to remind you of the word cleaner. The superpower of osteoclasts is that they can dissolve bone, and they do so at this ruffled border, which is in contact with the bone, which is where they secrete enzymes and acids. And in dissolving the bone, this releases calcium into the body. Once the osteoclast has dissolved away a pit, the osteoblasts are recruited by, amongst other pathways, osteoclasts. The osteoblasts come in to fill in that pit, and osteoblasts always work in groups, unlike osteoclasts. Incidentally, despite the two types of cells being so closely paired to each other, osteoblasts come from a completely different cell lineage from osteoclasts, and these secrete this soft bone tissue called osteoid. In this picture I've drawn, these osteoblasts are secreting new osteoid, which is soft bone tissue and is bone which hasn't set, so it's soft. And this doesn't become hard until calcium and phosphate is absorbed into it, and this is what then sets it. This is the process of remodeling, and the activities of osteoclasts and osteoblasts are tightly coupled to maintain bone homeostasis. Otherwise, bone disorders such as osteoporosis will manifest. And then in the process of creating new bone and filling in pits, some of the osteoblasts will become submerged into the osteoid and will then differentiate into their final form, which is osteocytes. Osteocytes produce long dendritic-like arms which reach out to each other to form a network before the osteoid sets. And once set, the osteocytes are entombed within the hard bone tissue, but are able to signal to each other via their arms. Osteocytes also secrete various signaling molecules which also influence osteoblasts and osteoclasts. So osteocytes act as mechanoreceptors, responding to vibrations caused by weight-bearing exercises, which then triggers them to release signals to induce bone building and thus increase bone mineral density. And here is an image from Wikipedia, which shows the network of osteocytes embedded throughout the bone. And you can imagine how they might talk to each other via their dendrite-like arms, and can also communicate with the osteoclasts and blasts on the bone surface. And this illustration is to show how the three types of bone cells communicate with each other via a multitude of different signaling molecules, of which I'm pretty much only going to be talking about two in relation to the mechanism of action of the osteoporosis drugs available. But just know that the mechanisms of action I will only cover a small fraction of the various different signaling communications which go on between osteoclasts and osteoblasts and osteocytes. In this illustration that I drew showing one osteoclast and a team of osteoblasts in action, but actually osteoclasts and osteoblasts are not simultaneously present at a particular pit site. So first, the osteoclast is there to form resorption, creating the pit, and this process may take around 3 weeks. And then a reversal phase occurs during which the osteoclast activity tapers off and then activates and recruits osteoblasts and then dies after its exertive efforts. So actually this reversal phase is not fully understood, may take around 5 weeks, after which the osteoblast then goes into bone formation mode to fill in the pit, and this bone formation phase lasts for around 3 to 4 months, quite a lot longer than the resorption phase. So these numbers vary with site in the body, skeletal health, and any medical treatment. And in some conditions, including osteoporosis, there is an increased duration or even arrest of the reversal phase. And this pit, with the coordinated team of osteoclasts and blasts working together on this particular site, are collectively known as a basic multicellular unit, or BMU. So bone formation and resorption are in balance. In normal human adults, the remodeling process in a particular site lasts between 6 and 9 months, and 10% of the skeleton is replaced every year.